Hi class, today's lesson will be on the topic of surface area of prisms. So the term surface area is referring to the sum of the area of all the faces that make up a 3D figure. Now, one way we can visualize surface area is by taking a 3D shape and then flattening that object out by looking at all of its two-dimensional shapes. So these examples that I have down below right here, one is an example of a triangular prism, which has a total of 5 faces. So imagine this was like a box that was in this shape, and if we were to take all the sides and then flatten out that box, we would have a total of 5 2D shapes that make up our 3D figure. And the same idea with a cube having 6 faces. If we were to take all 6 faces and then flatten it out, then we would end up with the following type of diagram. So we call these two-dimensional views right here of the triangular prism and the cube, we would call these nets. So a net is just a two-dimensional representation of the surface area of any type of 3D figure. Now, there is a step-by-step process in how you go about calculating surface area. And it's 3 steps in total that you would take. The first thing you would want to do is make sure you identify all the faces of the object and their measurements. So that's a very important thing to do first. Once you've done that, then calculate the area of each face. Once you've done that, add up all the faces, all the area faces to find the total surface area. So those are the 3 steps. Identify the faces, find each face's area, and then add them all together. So let's take a look at this example down below. We have a rectangular prism that has the following measurements. So all of these edges, these long edges, represent 30 meters. And then these short edges on the side make up 12 meters. So the first thing we're going to do is we're going to look at the net figure. So imagine that we take this box and then we would open it up and flatten it out. We would end up with these types of shapes right here. We have a total of 4 rectangles and 2 squares. And you'll notice that I took the measurements as reference and then filled them out according to the diagram over here off to the side. It does take a little bit of practice to do, so always make sure that you're checking and going back carefully when you go from 3-dimensional to 2-dimensional to make sure that you've labeled all your measurements correctly. Another thing I like to do just to help me visualize it is I like to label each face so that I know which part of the prism I'm dealing with. So I went ahead and labeled the left and the right face to represent these squares. And then the top and the bottom, you'll notice that there's a gap between them because, again, imagine you were to take this part of the 3D figure and you were to unroll it out this way, then the top and bottom face are opposite and congruent of each other. The same would be true of the back and the front. So there's our net diagram. Now the next thing we're going to do is we're going to find the area of each one of these faces. So let's start with the front and the back face. So the front and the back face are both rectangles and their dimensions are 30 and 12. Well, if you remember, to find the area of a rectangle, it's just length times width. So all we're going to do is 30 times 12 for both of these measurements. So 30 times 12 would give us 360. All right, so we found those 2 areas. Now let's find the area of the left and right face. So we look at our dimensions. So these are both squares. So 12 times 12 to find each one of these areas. So 12 times 12 gives us 144. So there are measurements for the left and right face. And now we look at the top and bottom faces and look at their edges. Well, the top face is 30 by 12, so 30 times 12 for that one, which gives us 360. The bottom face, long edge is 30, and we know that this edge has to be 12 because it is opposite and parallel to this edge that we identified over here. So 30 times 12 gives us 360. All right, so we have all of our area measurements. So now the last thing we're going to do is add them all together. So we've got 1, 2, 3, 4, 5, 6 areas in total that we're going to add together. So we've got 360 plus 360 plus 144 plus 144 plus 360 plus 360. So we're going to add all those together to find the total surface area. When you add that all up and work it out, you should get a grand total of 1,728. And our unit of measurement, since the surface area would be a square unit of measurement, so we would write it as 1,728 square meters. Let's take a look at this next example. We have a triangular prism this time. So let's think about how many total faces that we have. So it looks like the front and the back face are both triangles. Makes sense, it's a triangular prism. And then we've got a total of 1, 2, 3 rectangles that make up the lateral area of this figure. So it looks like we've got a total of 5 faces altogether. If you need to, pause the video right here and see if you can figure out what the net diagram would look like for this figure. So if you flatten this 3D figure out, the 5 faces, here's the way how I ended up drawing my net diagram. It might look slightly different from the way how maybe you visualized it, but as long as you've got a total of 5 faces, you should be good to go. Now, one important thing to keep in mind, again, always double check your dimensions for especially the rectangular faces to make sure you got them all correct. So this is my bottom face right here. I'll go ahead and label that right there. So that's my bottom. This is my front face, and this is my back face. Now, this face over here represents the left side, and this face represents the right side of my figure. That way you know how I went about visualizing the shape right there. And I went ahead and filled in the known measurements all the way around my figure. That way I know what measurements that I'm working with all the way around it. All right, so that's step 1. Now we're going to move on to step 2. Let's tackle the front and back faces. Both of these are triangles. Now, to find the area of a triangle, I just want to remind you of the formula. To find the area of a triangle is the base and height measurement of the triangle divided by 2. Now, since we're working with right triangles, the base and height measurements are going to be the legs of the right triangle. So we're going to use 8 and 15 for both of these triangles to represent the base and height measurement. So 8 times 15, then we would divide that by 2. Same would be true for the back face. So if we were to work that out, let's I'll have my calculator off to the side over here. So 8 times 15, and then divide that by 2. So we end up getting a total area of 60 for both the front and the back face. Let's work with the bottom face now. So the bottom face is 15 and 10 for our length and width. So 15 times 10 would give us 150. Now our left face, if we look at the dimensions carefully, looks like the short edge. Remember, if we were to fold this back up again, this edge lines up with this segment of the right triangle. So this would be an 8 by 10. So 8 times 10 would give us 80. And then the right face is a 10 by 12. We got 12 from the hypotenuse of this right triangle. So 12 times 10, if we work that out, that gives us 120. So now the last step will be to add all 5 of these areas together. You can pause right here and work it out, and then play the video once you find your answer. So I've got all my areas. I'm about to add them all together. So once you add all 5 of those measurements together, you get, let's see, a grand total of 470. And don't forget your unit of measurement, and that will be, for this problem, meters squared. I hope you found these examples helpful. Please let me know if you have any questions. Thank you.